This video explains Anritsu's IP data throughput testing solution for 5G devices. Part 1 introduces our IP data throughput testing solution. In 5G high-speed, high-capacity communications, fixed wireless access services, known as FWA, are evolving rapidly due to the drive for digital transformation and increased demand for remote work and home entertainment. In the process of developing wireless communication modules and IoT devices, such as customer premises equipment for FWA known as CPE, checking connectivity for many frequency bands according to the service status of telecommunications carriers at each product destination is essential. Improving the end-user experience, such as receiving services at good speeds, requires increasing the IP data throughput of CPEs and modules, and simultaneously supporting multiplex carrier aggregation and high-order MIMO. On the other hand, there are many possible thousands frequency band, CA, and MIMO combinations, presenting a challenge to checking the connectivity of each frequency band comprehensively and improving the efficiency of IP data throughput testing. Our radio communication test station MT8000A is a test platform for verifying 5G devices and supports both SA and NSA systems. The MT8000A can simulate base stations, making it easy to establish a call connection test environment with a 5G base station without putting the 5G devices into test mode. In addition, the MT8000A has multiple software options for different purposes, including RF testing, protocol testing, and throughput testing. These options can be installed in one MT8000A and switched as needed. This is an overview of the enhanced RF module MT8000A033 RF hardware option used with the Smart Studio NR-IP Performance MX800-1071A software. These are the main MT8000A033 specifications. One module can transmit 8 signals and receive 4 signals, respectively. Up to 2 MT8000A033 modules can be installed in the MT8000A to support transmitting up to 16 signals and receiving up to 8 signals with one MT8000A. The supported frequency range is 400 MHz to 7.125 GHz for FR1. The supported maximum transmission bandwidth is 1200 MHz for internal bandwidth and 800 MHz for occupied bandwidth, OBW. This introduces the RF sharing function that combines and outputs 2 or more signals at separate frequencies from one internal signal generator in the MT8000A033. Each MT8000A033 module has 4 RF connectors called TRX1 through TRX4. Each MT8000A033 module also has 2 signal generators. The signal generators in slot 1 are TXA and TXB, and those in slot 2 are TXC and TXD. Each signal generator can generate multiple in-phase and quadrature phase IQs up to bandwidth within the 1200 MHz while arranging those signals as desired. This is called RF sharing function that can generate multiple IQs. This example shows an ENDC configuration with downlink 2CC4x4 MIMO on the NR side and downlink for CC4x4 MIMO on the LTE side. The LTE side consists of 4 frequencies separated by 2.1 GHz, 1.8 GHz, 2.6 GHz, and 700 MHz bands. In this example, as shown in the right figure, the 2 FR1 band CCs N40 and N78, with different frequency bands, are generated at TXA and TXB at the slot 1 side, respectively. At slot 2, LTE bands B1 and B7 are combined at TXC adds to generate 2CC, and LTE bands B3 and B28 are combined at TXD to generate another 2CC. These combined LTE bands B1 and B7, and bands B3 and B28 are generated respectively within the 1200 MHz bandwidth, resulting in an RF sharing relationship. All band signals are output from each RF connector TRX1 to 4 in slots 1 and 2 as downlink 4x4 MIMO. Next, we introduce the Smart Studio NR IP Performance MX800 1071A software. This software with simple and intuitive operation has a unique state machine GUI allowing users to simulate 5G SA and NSA network environments. Furthermore, complex test script editing is not required, so user need no proficiency in 3GPP protocols. Increasingly complex 5G test parameter setting is simplified by squeezing parameters relevant to throughput testing, and it contributes to minimize the parameter tuning during measurement preparation. Out of the many 5G devices function tests, this MX800 1071A software is specifically for testing data throughput at the IP layer. Either one MT8000A with MT8000A033, or two MT8000A units with each of the MT8000A033 and 031 options meet the maximum throughput requirements for testing FR1, SA, NSA and LTE supported by the latest chipsets. Since using only the MX800 1071A software and the MT8000A can simulate both 5G NR and LTE base stations, users do not need another LTE base station simulator. The MX800 1071A also has comprehensive support for multiplex CA and high-order MIMO provided by leading-edge chipsets and modules, as well as many frequency bands used by operators worldwide. MX800 1071A operation is simple and intuitive. This software has plentiful experiences of verification with advanced chipsets, providing powerful support for customers' quick and stable launching a call connection test environment.